Hello, I will be walking you through the visual verification of the accessories kitting process through Vision Inspection System, including AI technology. This is for Team 10, comprised of Madeline Jackson, Janae Cucci, Ethan Plummer, and Mackenzie Stevens. This project is sponsored by Stryker. The main objective of this project was to utilize a visual detection software to verify correct parts within the kitting trays. An example of a kitting tray is shown on the right with various parts in their specific place. The goal of this project is to reduce the current rework rate from 35 to 0%. The current process involves a manual visual check to ensure that all of the parts are in the correct spots. This can be tricky with part size variability as well as subtle differences in the parts. Some constraints of this project: the system must fit within Stryker's table setup, which is 243 centimeters by 73 centimeters. The kitting tray must fit within the stand that we fabricated for this project. We also wanted to keep in mind the minimum field of view for the vision system when working with the kitting tray, and we wanted the project to be able to function within the facility lighting and withstand interference from foot traffic. The vision system our team selected was the Keyence IV4. This program visually highlights each region, has autofocus, a large field of view, and utilizes software like AI Differentiate and AI Identify to correctly identify all types of parts. A decision matrix is shown below to compare different vision systems the team looked at before deciding on the Keyence IV4. For our final project, we researched and selected applicable vision systems for the project, designed and developed a verification system utilizing AI-equipped vision technology, developed a validation program to ensure high accuracy of verification of the system to ensure that not only our training was done correctly, but the IV4 possessed all the capabilities needed for the scope of the project. The team also compiled several operating procedures and documentation per Stryker and industry standards to help ensure for a seamless transition once this project moves over to the Stryker facility. In total, we wanted to reduce the amount of rework from 0% or from 35% to 0%. Here's a video demonstration of our project in action.
We have a vision system with our kitting tray. Our vision system has a visual indicator, as you see right here. And these colors are green, that means everything looks good, right, and red indicating that a missing part or the part is misplaced. I'll remove a single part from the kitting tray, and our system will detect that a part is missing, indicating the right indicator lights shown above. And when I put it right back, it'll take a little bit to think about to show that it's green of it's good. Now, if you see here, this is how our system is displayed. Each circle or square that's green indicates the part is there, and also indicating an OK on top. Removing the same exact part, you will see that the system realizes that part is missing, showing a no good or a red. There's also other displays within it. We have 3 floating parts right here. So if I move this around, it should still understand that the part is still in there. Move it one more time. Still showing that it's good. We have alternatively located parts that when I move them into their second location, should still display a good.
We would like to thank our advisors, Dr. Jang and Dr. Kirkpatrick, as well as our sponsors at Stryker, Asana Med and Rose Strait. Thank you for your time.